Now, the Born postulate, this is one of the postulates, but we're not going to give it a number because we're going to see later that this is going to be a corollary to another postulate that we're going to make. But for now, this is a postulate that we're going to introduce this because this is traditionally how this psi is interpreted. Okay, so psi itself has no meaning, no physical meaning. Okay, and the reason for that is psi itself can be the value of psi can be a complex number. If the value of something can be a complex number, then it has no physical significance. It cannot have a physical meaning because everything in our physical world is associated with a real number. Okay, so psi itself has no physical meaning. So if you want something out of psi that has a physical meaning, you extract a real number from psi. So one way you can extract a real number from psi is to take its the square of its absolute value. Okay, so multiply psi by its complex conjugate. Psi star is a complex conjugate. Multiplied by psi, that gives you the absolute value of psi squared. That is called a probability density function. What does probability density function mean? Let's illustrate that with, let's say you have a particle that's constrained to just move in one dimension. Okay, so here you have a one particle, one dimensional system. So psi is just a function of x and time, right? So if we were going to take the square of psi, so if you take the square of this, that means whatever it is, it can be complex or real, takes its complex conjugate, multiplied by the function itself, you get psi squared, right? Integral of psi squared dx, okay? If you integrate psi squared dx from x1 to x2, that is going to be interpreted as the probability of finding the particle between x1 and x2. Okay? So, in other words, psi squared dx, okay, is the probability of finding it between x and x plus dx. The value of psi squared at x, multiply that by an infinitesimal amount dx, okay, that is the probability of finding it between x and x plus dx. So, since psi squared dx is the probability of finding it between x plus dx, what is the unit for psi squared? What's the unit for probability? A probability is just a unitless number between 0 and 1, right? So what's the unit for x? A unit of length. So something like meter would be an SI unit. So what would be the unit for psi squared? Per meter. So in other words, when you say probability density, what we mean is probability per unit length. You have to integrate it over a finite length to get the actual probability. Or you multiply it by an infinitesimal distance to get the probability within that infinitesimal distance. Okay? So psi squared is called a probability density function. What if we were doing 3 dimensions? Three dimensions, psi is a function of x, y, z, t, right? So your psi squared, then, you'll have to integrate it, okay, with respect to x, y, and z. Integrate it over an infinitesimally small volume with length, width, and height of dx, dy, and dz. So this is dv. Okay, so this thing right here is a volume unit. This is in SI, this would be in meters, this would be in meters, this would be in meters. So what would be the unit for psi squared if it is if it's a 3-dimensional function? Per cubic meter. Anything per cubic meter, anything per unit volume, okay, per unit length, per unit area, that's called a density function. So mass per unit volume is what? Your first encounter with the word density, right? Density of an object is mass divided by volume. Mass per unit volume is the mass density. So the complete phrase for that is actually mass density.